At a carnival, a game costs $1 to play. Your chance of winning is .2, and if you win, the carnival operator will give you back $4. What's the expected net gain per play? So now that there's a cost involved, there's actually more than one way to calculate this. I'm going to start with the method of calculating the net gain and net loss for each outcome. So how does that work? We need the probability of a win times the net gain on a win. Then we'll have to multiply the probability of a loss times the net gain on a loss. Now, what do I mean by the net gain? I mean that we have to take into account both the revenue that we would get for the win, $4 from the game operator, but take into account the fact that we paid $1 to play. So you walk up to the carnival operator with your dollar, you give the operator the dollar, you win the game, and the operator gives you back $4. So what's your net? Well, it's not 4, because one of those dollars was yours originally. So we got to subtract them to get the net, which is actually 3. That's what you walk away with. You're $3 better than you were when you walked up. All right, we'll do the same for a loss. The complement of 0.2 would be 0.8. And if you lose, the operator's not going to give you any money back, but they're still going to take your dollar, see? So that's what I mean by the net. The net gain on a win is $3. And the net gain on a loss is negative. You lose $1. All right, so now we want to calculate this. And if it comes out 0, that means it's a fair game. If it comes out positive, then that would be good for the player. It's a game you'd want to play because chances are you're going to get more revenue than you pay in costs. But this one comes out negative. Negative 20 cents per play. So that means if we were to play this game an infinite number of times and average all the results, we would have lost on average 20 cents per play. So is it a good game to play? No, it's not. Let's see if we can calculate that same expected value, though, using a slightly different method. This is separating the revenue from the expenses. Now, your net profit is always the revenue minus the expenses. Revenue is the money coming in, and the expenses is the money going out. So in this method, what we do is you multiply the probability of a win times the revenue that you get on a win. And you can multiply the probability of a loss times the revenue on a loss. But those don't take into account the costs, so we take into account the costs at the end. All right, so let's see how it's just a little bit different setup, but it actually gives us the same result. So probability of a win is 0.2. The revenue is the money that you get from the carnival operator, $4. That's the payout on a win. But when it comes to losing, you're not going to get any money back. Notice how I didn't take into account the cost of the game yet. That's because the cost is certain. You have to play it, you have to pay it every time you play. So it's a probability of 100% that we're going to have to pay $1. That's why we can put the costs on the outside. And what's really cool about this approach is that we actually get to see that we've got 80 cents in revenue per play and $1 in expenses per play. So see, it separates the average revenue from the costs. And you can see the balance between the two. So here, the reason why this game isn't fair is that the costs actually exceed the revenue. That's what makes our end result negative. Negative 20 cents per play. So that brings us to, what is the fair cost of a game? Well, when we break even, our revenue equals our expenses. And so since we've already calculated the revenue right here, we can actually see what the fair cost of the game is. It shouldn't be $1. The fair cost is the revenue. It's 80 cents per play. That's what the carnival operator should charge if they want the player to break even in this game. But of course, they wouldn't stay in business if they did that. They have to be able to pay themselves. They have to be able to pay for supplies and travel expenses and all that. It would be ridiculous to expect them to not have a positive net gain. So that's how casinos know that they are going to stay in business, is on those slot machines and other types of games that are similar. They make sure that the revenue paid to the player is not as high as the costs that the players are paying to play.